Yeah, okay, we're live. So now we're going to go on through something new called sequences and series. So this is going to be our introduction to sequences. Sequences. Okay, and today we're going to concentrate on a special case, which is the arithmetic. Now, it looks like you're going to say arithmetic, but it's arithmetic. So say it. Arithmetic. There we go. So we're going to talk about arithmetic sequences. I don't know who that was, but it wasn't mine. Okay. All right. So in order to get started, we got to talk about what a sequence is. A sequence is nothing but a collection of objects in an order. Now, the collection of objects in our case will be
shapes.
Numbers, yes. No, that's shapes. Okay. So I'm going to give you a sequence here. 3, 5, 7, 9, 11, comma, dot, dot, dot. That is a sequence of numbers. It's not a finite sequence. It's an infinite sequence because I have the 3 dots here, which means and so on. Okay. Now, if I were to ask you what the next term would be, you would say 13.
Oh.
Why?
Because the difference between all of them is 2.
That's right. This sequence has what we call a common difference. This difference here is 2. 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 We call that a common difference. Which makes this sequence arithmetic. And we're going to call that common difference B.
It's good for the second grade year.
I know, it's nice, isn't it? Nice feeling. All right. And then what we're going to do is we're going to define this term as A sub 1. That means A sub, S-U-B, because it's not a superscript, it's a subscript. Okay, so this is term A sub 1. This one would be term A sub 2. This one, the next one would be A sub 3, A sub 4, A sub 5. All right, now, sequences have domains and ranges. And I'm going to start off with a range because I think that's the easiest thing to discuss here. The range is nothing more than the numbers in the sequence, right? It's just the objects in the collection. That's the range. So the domain, let's talk about that. Let's say you are in line. And Connor is number 3. And Renee is number 5. And Lauren is number 7. Can you be in 1.5 place in line? You know what I mean? I mean, what I'm saying is Connor is first in line, second in line, third in line. Is there a 1.5 spot in line? No. So what is the domain?
3, 2,
All the, that's right, all the integers greater than 0. Now, we used to have a symbol for integers,
IR.
z, a fancy z,
That's always
but we want them to be positive. So we put a little plus. All right, so these, another word for these are the counting numbers. What you learned in preschool.
So is that like subscripts?
The plus is a superscript.
Or like the domain?
The domain?
Is the domain
Yes,
like a
yes. The domain is a subscript. This is, so the domain is, we call this n typically. N equals 1, n equals 2. That's your place in line. That's your position in line. Okay? Position in the sequence. So I'm going to ask you, are sequences continuous?
no.
No, they aren't. Why? You're right.
Big holes in the
Skip
middle.
all the
There's a bunch of there are a bunch of numbers between 1 and 2. I would say infinitely many. Yes, so sequences are not continuous, they are discrete. Okay. Now I just defined one sequence, a special sequence, which we call the arithmetic sequence, which means it has a common difference. So let's write out that definition. And we encourage that as D. Okay, now, wouldn't it be nice if there was some way, if I asked you, okay, what is the 1,000th term here? I mean, short
Ask
of
on the math league.
writing all of them out, what'd you say? It's going to be greater than 11. That is very bright. I like it. That's why we're in honors pre-cal. All good, right? And it's good that we're having fun. I like that. All right, so wouldn't it be nice if we had some way, other than writing down all 999 of them before we got to 1,000? And so I'm going to suggest to you that there's a way that we can find an a sub n, which is the general formula for the nth term. Yeah.
If you do 3 plus 2 and then n minus.
Yep, what we're going to do is I'm going to show you, we're going to derive it. Let's derive it. And I'm so relieved that everybody can see my screen. Well, I shared it with everybody this time. That was my fault before. Okay, so this is how we're going to derive it. So if on a test I ask you to derive it, you'd know how to do it, right? So first term here is a sub 1. Well, that's easy enough. Well, how do I get to the second term? What do you do to a sub 1? You add the common difference, which is d, so this would be a sub 1 plus d. That's easy enough. What if I wanted to get to a sub 3? I would take a sub 2 and add another d. So it would be a sub 1 plus d plus d. Everybody follow that? A sub 4? A sub 1 plus d plus d plus d. And should we go 4d next? We've done 3d. A sub 5 would be a sub 1 plus 4d.
Not 40.
4d, yes, as in David, not 4t, yes. All right, so can you make the gigantic leap here to what a sub n would be? A sub 1 plus
N minus 1D.
n minus 1 times d, which is what we're going to say. Yeah. And let's see why that works. Because right here I have how many d's? 4. Here I have 3. Here I have 2. And then here I have 1. You notice that it's always 1 less than the n position. And that's how we derive it. So this right here is the general formula for the nth term of an arithmetic sequence. Pretty easy so far, yes? Now, this is like the equation of the line. When we had y equals mx plus b, each line was specifically required to have a slope and a y-intercept, okay? Every sequence is going to be similar to that. We had to have m filled out and b filled out in the equation of the line. For sequences, for arithmetic, we always have to have what filled out? A sub 1 and d. Because that's what makes the sequence unique. All right? So let's do an example. And like I said, this is the general, oops, I don't want to use yellow. For an arithmetic sequence. So this formula is going to be very familiar to us, okay? So now I'm going to go back to the beginning with the sequence that we started with, which was 3, 5, 7, 9, 11, comma, dot, dot, dot. And we're going to try to find the general nth term for this. So we could say a sub n here equals 3, because that's a sub 1, good, plus n minus 1 times 2. Now your book and other folks will distribute that 2. So let's do that. A sub n here equals 3 plus 2n minus 2. And so then we get a sub n equals 1 plus 2n. Now, personally, I prefer this version of it because when I look at this version that I put in yellow, I can see the first term and I can see what? The common difference, right? What about this, the last line? Can I see the first term? No, it's gone, it's evaporated, but I can see the common difference. So I am absolutely A-okay, absolutely prefer you leave it like this. For those who are listening, like this means the yellow version, okay? Because then you can see the common difference and you can see the first term, all right? Now, I said, wouldn't it be nice if we could find the 1000th term, right? Which would be a sub 1000. So a sub 1000 equals, so what are we going to do? We're going to take and make n equal to 1000 in our equation. So this would be 3 times, or 3 plus 999 times 2, which is 2001?
Yep.
Because that's 1998 plus 3. So now that was a lot easier, I think, than writing out all of that madness. No? But Renee wants to write them all out. So then on the test it'll be A sub a million.
We'll need a lot of paper.
Yeah. A sub a million. Okay, so this is arithmetic sequences. That's not too bad, is it?
It's about the journey, not the final.
It's about the journey. It's the math journey, absolutely. I'm working on a website called www.mathjourney.com.
Are you actually?
Wow.
I know. Yes.
Really?
Yeah,
What are you gonna do?
I don't know yet.
You should sell some of them.
No.
Yeah,
Sell your video.
Sell.
For a lesson
Yeah, you
plan.
could. And sell like math t-shirts.
Like,
This is our pregnant pause. Okay, here we go. Given the sequence. 50, 44, 38, 32, comma, dot, dot, dot. Yeah, so first of all, is this arithmetic? Well, because not all sequences are arithmetic. They have to have a common difference, right? And Mr. Voss has said already, this is -6, -6, -6. So therefore, we have a common difference of -6. So D equals -6. And if I want to come up with the general form, or the general formula, some people call this a rule, you know, the nth term rule. So don't let that, for A sub n. So what are we going to do? We're going to say A sub n is equal to
50.
50. Good.
Plus 1.
N minus 1 times
-6.
-6. And we're going to resist the urge to simplify and leave it like that because we can see A sub 1 and D. All right. So let's, somebody give me a term you'd like to find.
$1 million.
A million.
Okay, how about like a really hard one, like
4,792.
Okay, 792. 1790. What did you say?
4,792.
There you go.
That's a nice and specific number.
I blame Renee. All right, so what are we going to do? 5 or 50 plus 4791 times -6. Now, if you didn't have a calculator, this is not too bad to do by hand, is it? So what do we get? A very large number, negative.
Negative 28,696.
And what does this physically mean? That means the number in the 4,792nd spot, if we were to go all the way down, right? A sub 4792 is negative 28,000, what'd you say?
696.
696. Yes.
So since the domain has to be only positive integers, does that mean that you can't go backwards from 50? Like you couldn't have a zero above?
Yeah. Our sequence is starting at 50, yeah. Now, there are some sequences that we will start at 0, but that's in calculus, so don't worry about that right now. We're going to start with 1 or 2. Okay, next example. Be obnoxious. We're going to do the same thing. I'm going to give the pen to somebody. Who am I giving it to?
Ooh, me.
Handwriting?
I think mine's a work of art. Mine
Wait.
in sequence that.
We're going to find the nth term, find the general formula for the nth term.
Number stamp. What? You said it instead of 2, please.
I know, I'm worried.
I'm worried.
So what happens now is you notice you have weakness, yes? So anytime
So
you
what-
write that down, you need to triple check what you wrote to yourself. Now it's note to self. And you know what? You're human. I have those things too. Like derivatives, cosine. I have to triple check every time.
What time are we finding here? Which one?
What?
Which one are we finding?
The nth term?
Well, okay.
We're not yet. We gotta find the general formula first. So what's a sub n?
Oh, A, so, yeah. Okay, come on.
Okay? Don't worry, Porter, I'll let you do one.
Oh gosh. A sub 1
Right?
plus
Okay.
sub 15.
So, yeah, so what are you gonna plug in? A sub n equals,
A sub n equals,
what's our first term?
32.
Yep, so a sub n equals 32 plus n minus 1, good, times d, which is 15. All right, so what term would you like to find?
I don't know. What you want me to find?
Negative 30th term.
No, we don't, we're not gonna go backwards.
No, backwards.
Positive. Michelle, what do you think? It doesn't have to be
The first
funny.
term.
791.
791, so we want a sub 791.
I just took this.
32 plus 790 times 15. Good, somebody's gonna help him out with that math, right? What is a sub 791 then?
I could do it by
Okay,
hand.
sure, do it by
You want
hand.
me to do it by hand? Oh, what does that say? What does that say?
Is that a 9 and a 9?
I don't know.
Yeah,
That's a
9.
9? Okay.
It's tough in public, isn't it? 11
It is, yeah. Okay, 11, 8, 30.
plus 32?
Yeah. Wait, that's 5, right?
Oh, it's a
Five.
5.
Yeah,
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 okay,
yeah.
okay, 5.
But
We
it's
thought it was a
five.
3.
You're
Didn't we
right.
think it was
I
3?
thought it was 3.
Okay, I feel better now. All right, so a sub 792, 791, I'm sorry. Do we get concurrence? Good. All right, nice job. You got to sign your name. What's your little signature?
Oh, I don't remember.
Yes, you do.
Write your entire name fully. I'll just.
No, what is
I'll
your
get
symbol?
I don't remember my symbol.
JB.
I don't remember it. I'll just.
Wow.
There it is.
Yeah.
Very nice.
There it is.
Where's this one?
Aww. Nice. All right, here we go. Now, what if I don't give you the first term?
You have to work backwards.
You got to do some work. So this kind of problem is, what if I given a term not a sub 1 and the common difference? So let's say we got a sub 13 equals 30. So that means the number in the 13th position is 30, and the common difference then is d equals 3 halves.
Could you plug it onto the general formula and then instead of plugging in the base of it, you plug in the n?
Right, so we're going to use the general formula. And I'm going to say they gave me n equals 13. So I can say a sub 13 is equal to a sub 1, which I don't know, plus, well, what's n minus 1? 12, so this is 12d. But I know a sub 13, which is I can substitute in this for 30 equals a sub 1 plus 12 times, well, they gave me d was 3/2. And so this is 30 equals a sub 1 plus, this is going to be 18. So a sub 1 here is 12. But I am on the hunt for the nth term. So a sub n for this sequence is going to be, now I know a sub 1. So it'll be 12 plus n minus 1 times my common difference, which was 3/2. And then how about we find something less bizarre like a sub 23, the 23rd term. Now we could go back by 3/2 several times, or up by 3/2 several times to get there, or we can use our nth term, right? Which would be 12 plus 22 times 3/2. So this is going to be 12 plus 33, which is 45. So a sub, the number standing in the 23rd spot will be 45. How are we feeling? This is nice and algebraic feeling, isn't it?
Oh, I can't remember what grade we did this.
You did do this though. That's great.
Wow.
Well, what if I threw you a monkey wrench and I give you two terms, neither of which is a sub 1? So let's say we have a sub 6 is 10, and sadly they won't be right next to each other either, right? Because that would be too easy. If I gave you a sub 7, would you know?
Oh, yeah, you know.
That would be way too easy, right? Okay, so a sub 21 equals 55. All right, so what am I doing now? I'm giving you two different.
Sorry, you guys, this is-
It's going to be a system, yes.
Oh, my.
But this is easy. Algebra, right? All right, so this is going to be n equals 6. That's going to be a sub 6 equals, do I know a sub 1?
No.
No, so it's going to be a sub 1 plus n minus 1, which is 5d. So that's my one equation. Well, no, I know that a sub 6 is 10. So 10 equals a sub 1 plus 5d. And then I know that n equals 21. Those are my two n's I've been told. So then I can say a sub 21 equals a sub 1, which I don't know, times 20d. But a sub 21 is 55 equals a sub 1 plus 20d. Now I have two equations and two unknowns. Now some people will use elimination here, but boy, this is a classic candidate for elimination because all I have to do ever when solving these is multiply something by -1. Because the coefficients in front of the a sub 1s will always be 1. So this we can say, we can line them up. 10 equals a sub 1 plus 5d. 55 equals a sub 1 plus 20d. And then I can take one of those equations and multiply them by -1. I'll just choose the first one. And we get -10 equals negative a sub 1 minus 5d. And then 55, I'm just rewriting it for ease of addition. And now we'll add them together. As we get groans from the other room. All right, here, these go away. And then we're left with 45 equals 15d. D equals 3. We're reverting to our algebra 1. But I'm not done yet because in order to have the nth term, I have to have an a sub 1. So what are we going to do?
Plug it in.
We're going to plug it in. And since this is elimination, it doesn't matter which equation we use. So I'm going to use the one with the easier numbers. No. I'm going to use 10 equals a sub 1 plus 5 times 3. So 10 equals a sub 1 plus 15. I'm having algebra 1 flashbacks. A sub 1 equals
-5.
-5. I mean, I did teach algebra 1 for 5 years.
Where?
Here. And so my equation is going to be a sub n equals -5 plus n minus 1 times 3. So those are pretty easy, right? And then we can find a sub 35 equals -5 plus the 34 times 3. And what does this give us? That's what? 97, yeah. Now let's show you how to do this on your calculator. What? We can do this on our calculator? Oh my goodness. But we have to change our mode. We need to be in what mode?
Function.
Sequence mode.
Sequence mode.
That's the last mode.
It's the last mode. That means we've touched every mode. Now mine's already in sequence mode.
I know, but there's 3D different.
Well, on yours there is. But okay, so everybody in sequence mode? Okay, I'm going to second quit out of there. And how do we get to the sequence function? Well, what is a sequence?
It's a collection of
It's
numbers.
a collection, but in other words, for a collection would be
It's
a
a list.
list. So we're going to go second list, and we're going to perform an operation, which is, I'll help you in 2 seconds, which is number 5.
I don't know how to get the.
All right, and I'm going to clear this out. Okay, now what you're going to do is put your expression in. You know what to do?
We don't have time to.
I know you do. Okay, so where's my expression for my nth term on this? What was it? Negative
What under operations?
sequence. SEQ? Okay, so no. So quit, second quit. All right, so what you guys are going to do is hit second nav. And you're going to go to the list menu, and sequence is number 1. And then the sequence command is number 1. Now you're just going to have to type in what your nth term is. What is your nth term? It's this. Oh, you didn't write it. You didn't finish writing it out.
Oh, I didn't finish writing what I did.
Your a sub n here.
Oh, okay.
Your a sub n is going to be -5 plus n minus 1 times 3, right? So that's what goes first. And then you're going to go comma n, comma start, comma stop. Okay?
So,
All right, so I'm going to type this in, -5 plus parentheses. Now what happens when you hit the X key now?
N.
You get n because that's sequence mode. N minus 1, you guys are going to have to go alpha n. Times what here? -3? No, it was +3, right? Is that right?
Yep.
Okay, so now I'm going to scroll down and your variable is n. You have to tell the calculator what the variable it is they're going to be plugging into. And then we're going to start with the first term and let's end with the 35th. Because that's what I did over here, right? 35th. 35th. And then, yes,
My calculator's old, so I want to do that.
I'm going to have to do it at a different time, okay? All right, and then I'm going to press enter. And so the command comes up. Do we have that command?
Wait, what's the step?
Comma n, and where are you going to start? At term 1, comma to term 35. And then parentheses, close parentheses, you go.
Okay.
And then you can hop up here and you can scroll over, okay, and see if you're right. All right, now everybody got this? Except for Miss Backo.
You put that 1%.
Sure, yeah, that's fine. Let me see your command. Okay, press enter. Okay, enter. There it is. Now you should have to scroll over. You just can't do that, or you can't hop up in order to scroll. It'll only may have to do it again. It's just okay. So, ladies and gentlemen, I need all eyes up here. This is a very important moment. When you press enter here, do you notice that you have a line of a sequence, right? You can, in order to see the rest of the numbers in the sequence, you do not hop up, which is what everyone thinks that you should do. You use the right arrow at the bottom here just to scroll over. Okay, you do not hop up, and if you hopped up and it's not moving, you have to redo the command for you to.
You should enter again.
Okay, so it's going to go all the way to 35, and hopefully we'll get to our number of, what did we expect?
97.
97. Now, wouldn't it be nice if I could get to 97 right away? Well, could I do the same command and start and stop at the same spot? And do 35 to 35? Yes? No? I'm going to start at 35, term 35, and I'm going to end at term 35. So 35, comma, 35, comma, I want it in increments of 1. There it is. Is that cool? So you start and you stop. Just now?
Yes.
I just started and stopped, because when you do your this is your a sub n, comma, start, comma, stop. I just started and stopped at the same number. And you really don't have to have the -1. By default, it'll do a -1. I mean, it'll do increments of 1 for sequence mode. All right? So what if you wanted the 1,000th turn? You could go from 1,000 to 1,000, right? Now, how do we get to the sequence command? What is the sequence? It's a list of numbers, right? So you go second list, and then you go to operations and hit sequence. All right? Good. Now, in your book, the very first problem in the homework looks a little scarier than it is, so I just wanted to go over that really quickly with you. Chapter 9. Okay. You guys have to do number 1 and 3. So just follow along here. This says find the first 6 terms and the 100th term of the sequences. Now, I am using a sub 1, a sub 2, a sub 3 as my terms. This one is defining a sequence as u sub n. Does it matter?
No.
V sub n. No, so if I'm going to do number 2 because you guys have to do number 1. So V sub n equals 4 over n plus 2. If I need the first 6 terms, what am I going to do? I'm going to let, whoops, because I'm closing PowerPoint right now. I'm going to let n equal 1 here. What happens when I get n equal 1? You get? 4/3. That's my first term. You see what we're doing? If I let n equal 2, that gives me the second term, which is 1. If I let n equal 3, that gives me the third term, which is, everybody following? N equal 4? 2/3. Okay, so I think you can do that now, so don't let that scare you. The next thing is it talks about a recursive function. I got 1 minute. Recursive. Now, I gave you the explicit formula. That means if I tell you what position I want, my formula is explicitly stating that a sub n is this, right? It's explicitly defined. You can have a recursive definition, meaning, let's say on number 6 here, they let u sub 1 equal -3, and then they say u sub k plus 1 equals u sub k plus 10. That means I have to get to the next term. What do I have to do? I have to add 10. This is a recursive definition because it depends upon the term before it. So I'm starting at -3, but this says if I want u sub 2, that would be u sub 2. That means I take u sub 1 and do what with it? Add 10. So this would be 7, 17, 27. You see, that's a recursive definition. This is recursively defined. And recursively defined only means that it's defined by the term in front of it. What did you do to the term in front of it to get to the next term? Does that make sense? That's all that is. All right, and so omit number 40 on the homework because I haven't talked about series yet. We're adding numbers up. I'll do that next time. And thank you for being patient.